everyone. Today we will be talking about the kinetic theory of gases and laws of thermodynamics. First, let's get started with the kinetic theory of gases, which is the behavior of gas particles, and it's based on five main postulates. The first postulate is particle motion. This explains that gas particles are in constant random motion, colliding with each other and the container walls. The second postulate is negligible volume. The particles show that they have no volume compared to the volume of the container. And the third postulate is that each molecule has no attractive forces from each other or the container wall. They have no intermolecular forces. And the fourth postulate is that collisions between gas particles and with the container walls are perfectly elastic, and there is no loss of kinetic energy each time they collide. The last postulate is that the average kinetic energy of gas particles is directly proportional to the temperature of the... Okay, so now we're going to move on to the four laws of thermodynamics. First, let's start with the zero law of thermodynamics, which states that if two systems are each in thermal equilibrium with the third system, then they are in thermal equilibrium with each other. So an example of this is when we have three containers. If the first container is at the same temperature as the second container is also at the same temperature as the third container, then the first and third container are also the same temperature. And next, we're going to talk about the first law of thermodynamics, also known as the law of energy conservation, which states that energy cannot be created or destroyed, only transferred and converted from one form to another. In other words, the total energy in a closed system remains constant. For example, when you burn wood, the chemical energy in the wood is converted to heat and light energy. No energy is lost, and it's all converted to another form of energy. Next, we're going to move on to the second law of thermodynamics, which states that in any energy transfer or transformation, the total entropy of an isolated system always increases over time. So entropy is a measure of disorder in a universe, which means that natural processes tend to move towards a greater disorder or entropy, which is why it always increases and never decreases. And an example is ice melting in a warm room. The structure of ice breaks down, which increases the orderness, the randomness of the system, which increases the entropy. And last, we're going to talk about the third law of thermodynamics, which states that as a system approaches absolute zero, the entropy of the system approaches a constant minimum. So absolute zero is the lowest possible temperature where particles have minimal kinetic energy. At this point, subsystems have zero entropy, representing maximum order. So even though absolute energy is impossible, this helps us understand how materials behave in very low temperatures. So the law of thermodynamics are principles that explain how energy moves and changes in the universe. It not only helps us design better systems, it also gives us a deeper understanding of the world. Thank you for watching, and I hope this is helpful.